Hello guys, in this video we are going to discuss the solution of the problem alien dictionary. Hello guys, in this video we are going to discuss the solution of the problem alien dictionary. So let us look at the problem statement. The problem statement says given a sorted dictionary of an alien language having n words and k string alphabets of a standard dictionary, find the order of characters in the alien language. Note: many order may be possible for a particular test case, thus you may return any valid order and output will be 1 if the ordering of the string returned by the function is correct, else 0 denoting incorrect string returned. So let us try to understand this problem with the help of an example. So let us say this is the dictionary which is given to us. It comprises of 5 words and the number of unique letters it has is 4. And as we can see, the unique letters over here are A, B, C and D. Now the question says given these information we need to find the correct ordering between A, B, C and D. Please note this dictionary is given in sorted order. So the correct ordering of letters is B, D, A and C, and this is what we need to return. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So in order to discuss the solution of this problem, let us first discuss how we are going to find the ordering between the letters. So let us discuss how we will be able to find the ordering between letters. So in order to discuss this, let us take the first two words which we have. So the words which is given to us is BAA and ABCD. So let us say these are the two words from the dictionary, and please note these words are coming from dictionary. That simply means if BAA is coming first, then BAA is alphabetically lesser than ABCD. Now, since it is alphabetically lesser than ABCD, what we are going to do is we are going to set a pointer over here which is at the beginning of word 1. Similarly, we are going to set another pointer at the beginning of, and we are going to compare whether they are same or they differ. In the case they are differ, so if they are same, we will just update our both the pointers. If they differs, then we have an ordering between them. And the ordering is, we can say that B is less than A. That simply means B comes before A. And once we have obtained an ordering, we are going to move to the next pair. So the next pair in this dictionary, as you can see, is ABCD and ABCA. So let us look at ABCD and ABCA. Now again, we are going to set a pointer at the beginning of these words. As we can see, AA matches. Similarly, BB matches and CC matches. Now D and A does not match, because of which we came to a conclusion that D is less than A. Now once we have obtained an ordering, we are going to move to the next pair. So the next pair is ABCA and CAB. As we can see, the first letter itself differs, because of which we get our ordering, which is A is less than C. And similarly, let us operate on the next pair. So the next pair, which is our last pair, is CAB and CAD. Now let us operate on this pair. So these letter matches, because of which we are going to move forward. And as we can see, B and D differs, because of which we came to a conclusion that B is less than D. So from the dictionary, we are able to conclude this information, which is B is less than A, D is less than A is less than C, and B is less than D. Now using these conditions, let us see how we will be able to obtain our ordering. So as we can see, B is less than A. So B and then A. Then as we can see, D is less than A. So D has to be over here. Or it also might be possible that D is here. As of now, with these two conditions, we don't know. So for now, these are our two ordering which we have. Then the third condition is A is less than C. So A is less than C. And the last condition is B is less than D. So we realize that B is less than D, because of which this is not a valid ordering. So towards the end, we have obtained our ordering, and this is what we are going to return, which is B, D, A and C. Now, humanly, it is possible for us to analyze these conditions and come to this conclusion. But how do we write this, or how do we code this in a program? So for such situation, our go-to solution is topological sort, which simply means what we have to do is we have to represent these equation in the form of a graph. And once we have represented these equation in the form of a graph, then we are going to use topological sort in order to solve our problem. Now let us take this condition and build a graph from it. So what we are going to do is each letters we are going to represent it as a vertex of a graph. So A, B, C and D. These are the vertex of my graph. A condition B is less than A simply means that between node B and A there is an edge. And please note, these are directed graphs, since here we are dealing with condition which is less than, because of which we need to represent in the form of a directed graph. So B is less than A simply means there is a directed edge from vertex B to vertex A. Now using this, let us form our graph. So there is an edge from B to A, there is an edge from D to A, there is an edge from A to C. So this is the graph which we have built on the basis of condition which we have. And once we have this graph, we want to order the vertices. And how do we want to order the vertices? Well, the way we want to order these vertices such that it honors this condition. And let me explain this. So for instance, if we look at this edge, which is an edge between B to E, in order for this edge to honor the condition, we have to traverse the vertex B first, and then we have to traverse vertex D. And why is this the case? Because B is less than D. Similarly, if we take this edge, which is an edge from B to A, here the condition is B is less than A, which simply means before visiting node A, we must visit node B. And the way we will be able to do this kind of ordering is topological sort. Now let us take this graph and apply the topological sort in order to see how we will be able to get our ordering. So let us say this is the graph which we have, and we want to order A, B, C, D. And these are my 4 places where I want to place A, B, C and D in a particular order. So let us say we start from node A. Now as we can see, from A there is just one transition, which is from A we can move to C. Now what we are going to do is we are going to move to C. So now we are at node C, and from node C we can't go anywhere. So that simply means this is my leaf node, because of which we are going to mark C over here, which is towards the end of our ordered list. And why is it so? Because as we can observe, C is a vertex from which we can't go anywhere. So that simply means it is safe to place C towards the end of our ordered list. So once we have placed C towards the end of our ordered list, let us mark C to be visited. Now, after marking C, we recurse back to A, and as we can see from A, we are not able to go anywhere, because of which now it is safe to mark A also as visited and place it in our ordering. So what we are going to do is, we are going to place A next to C, and we are going to mark that A has been visited. Now from A and C we can't go anywhere, so what we are going to do is we are going to pick another element from this. So now let us pick node B, as we are at Bth node, and from B node we can go to 2 places, which is A and D. Now since A is already visited, so we are not going to visit A again, but we are going to visit D. So from node B we will go to node D. And once we are at node D, we realize that we will be able to move to only one location, which is A. And since A is already visited, which simply means from D we will not be able to go to any other location. So that simply means now D becomes the leaf node. And now since D becomes the leaf node, we are going to mark it over here. And let us mark that D has been visited. And towards the end, we will come to B. And we will place B over here. And in this way, using topological sort, we will be able to order the letters of the dictionary. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So let us say we want to find order and a dictionary is given to us. And two numbers n and k is also given to us. So please note, in the dictionary words are given, but words are composed of letters. So first thing which we need to do is we need to find the letters. And these letters, we are going to assign a code to these letters. So we will write a function which will take this dictionary and return letters and code to us. So let us write a function return letters and code, and it takes dictionary as an input. So let us discuss little bit about letters and code as well. So this is the dictionary which is given to us. From here, we want to first identify the letters. So the letters over here are A, B, C, and D. So what we are going to do is we are going to assign a code to these letters. So let us say we are going to assign 0 to A, 1 to B, 2 to C, and D, 3 to D. So this is the letters which we have. Similarly, we will also have a code dictionary, which is just the reverse of this, which is 0 corresponds to A, 1 corresponds to B, 2 to C, and 3 to D. So this is our letter and code dictionary. Now let us proceed forward. So we have our letter and code dictionary. Now once we have our letter and code dictionary, what we are going to do is we are going to find num, which is equals to len of list of letters dot keys, which is just how many letters are there in the dictionary. So that information I am storing it in num variable. Now once we have these two information with us, what we are going to do is we are going to build a graph. And let's say we have a function for this, which is prepare graph. And to this function, we are feeding dictionary, letters, and num. Num simply represents the number of vertex in a graph. From graph perspective, num represent numbers of vertices. Now once we have graph, all we have to do is, in order to find our answer, we just have to perform topological sort. And to this, all we have to pass is graph, num, and code. And then what we are going to do is we are going to return answer. Now let us look at these individual functions in order to complete our understanding. So first let us look at the return letters code function. And to this function, dictionary is our input. So for this, we are going to take letters a dictionary, code a dictionary, and num equals to 0. Now we are going to iterate on each words of the dictionary. So for word in dictionary, and then let us iterate on each letters of the word. So for ch in word, then we are going to check if this ch has already been observed. If it is already been observed, then there will be an entry in the letter dictionary. If it is already observed, all we have to do is we have to move to the next element. So I'm just marking it as continue. Otherwise, what we are going to do is we are going to put this character ch in our letter. So letter of ch equals to num, which is the code for this letter. And similarly, let us build our code. And similarly, let us build our code dictionary as well. So code of num is equals to ch. And then let us increase our num by 1. And using this loop, we will be able to build our letters and code. And all we have to do is we just have to return letter and code. So that's about this function, folks, which is return letters and code. Now let us look at prepare graph function. So to prepare graph function, as we see, dictionary, letters, and num will be our input. Now let us look into this function. So the first thing is we want to initialize our graph. So the first thing which we want to understand is what is the total number of vertices. Well, the total number of vertices is equals to the total number of letters which we have, which is already there in this num variable. So let us have it. So this is our adjacency list. We are representing graph in the form of adjacency list. Now once we have this, now let us populate this graph. And the way we will be able to populate this graph, please recall our discussion. we want to find this condition. And how we were able to find this condition? Well, we were taking two words and then we were comparing those two words letter by letter and the position where it differs. So for instance, in this word pair, at the first position itself the letters differ, so that simply means B is less than A, and in terms of graph that simply means there is an edge from B to A. So now let us use that in order to build our graph. So for I in range of len of dictionary minus 1. Now let us take two words. So my word 1 is dict of I and my word 2 is dict of I plus 1. Now let's have a j equals to 0 and let us iterate on these two words while the characters are similar. Now let us iterate on these two words while j is less than len of word 1 and j is less than len of word 2, and these two characters are similar, which is word 1 jth character and word 2 jth character are similar. If that is the case, let us increase our pointer by 1, and once the loop breaks, word 1 will become my vertex x. So this is my vertex x, and word 2 will become my vertex y, and there is an edge between x to y. So let us do that. If j is less than len of word 1 and j is less than len of word 2, then my vertex 1 is letters of word 1 of j. Please note, letters corresponds to letters and corresponding code, which is this. And folks, the reason why we are converting letters to code is because when we traverse our graph, it will become easier. Otherwise, it will be difficult to traverse using letters such as A, B, C, and D, wherein the ordering is also not there. So my vertex 1 is this and vertex 2 is letters word 1, sorry, word 2 j. So now this is my vertex v1 to v2. Now let us have the edge between v1 to v2. So in the adjacency list, all we have to do is there is an edge between v1 to v2. And in this way, we will be able to build our graph. Once we have built our graph, all we have to do is we just have to return this graph. So that's about these two functions, folks, which is return letters and code and prepare graph. Now let us look at our final function, which is topological sort. And for topological sort, we have graph as an input, number of vertices, and code. And please remember, code is from 0 to A. So letters have A to 0 mapping and code has 0 to A mapping. So this code is what we will be needing over here. Now, what we are going to do is we are going to build our visited list. And initially, since none of the nodes are visited, so we are going to mark everything as false. And then let's have a stack, and we will see in a bit how we are using this stack. Then let us iterate on for I in range of vertices. Now let us check if this vertex is already visited. So if this is not visited, ith vertex is not visited, then in such case we want to perform topological sort over here. So let us perform topological sort, and let's have a topological sort util to perform the topological sort. And to this, all we have to pass is graph, the vertex, visited list, and stack. And using this for loop and this topological sort util function, we will be able to do a topological sort, and the values will be stored in our stack. And since, as we have seen in topological sort, the last node or the leaf node will be visited first, because of which the last node or the leaf node will be at the bottom of the stack. So the stack will contain the ordering wherein the first node visited by the topological sort is at the bottom of the stack. So what we are going to do is I we are going to set it as len of stack minus 1. So the top of the stack will have the first node to be visited, and we are going to do while I is greater than or equals to 0, and then all we have to do is prepare our answer list, and answer list will be equals to answer.append. So my ith node is the first node, but since ith node is in the form of 0, 1, 2, but we need A, B, C, D, so that info is there in code of I. And then let us decrement our ith pointer, and in this way we will be able to prepare our answer, and towards the end all we have to do is return answer. Now let us look at this topological sort util function as well. So topological sort util function is very straightforward. All it takes is graph, source, visited, and stack. Now the first thing which we are going to do is we are going to mark source as visited. Then we are going to check what all nodes are reachable from this source. So for target in graph of source. Now if target is not already visited, then let us perform the topological sort util over here with graph. And now what is my source? Well, the source is my target, and visited and stack. And once we have visited all the nodes, all we have to do is we have to update our stack. So stack dot push source, and in this way we will be able to perform topological sort util. So that's the discussion of pseudocode, folks. Now let us see how we have implemented this in Python. So the Python implementation is also the same, folks. Now since the code is a bit lengthy, I'm not going to go over it, but like always I will be pasting this in our comment section, so you can refer the code from there. For now let us just submit our solution. So our solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.